Thank you, Sarah. Hi, everyone. Thank you for joining today. As Sarah says, I'm going to be talking about how you can use some of the Chef capabilities to automate some of the auditing requirements of GDPR. So I'll just quickly introduce myself. Looking at the attendees, it looks like I've met a lot of you, so thanks a lot for joining. But for those of you I haven't met, my name is Joe. I'm a Senior Solutions Architect at Chef, which means that I look after the technology, product side of things. I run workshops, POCs, all that kind of good stuff. Within the EMEA team, in the European team, I'm the subject matter expert for compliance. And I also focus on Microsoft technologies and do a lot of work with Microsoft from a partner perspective. My background is in cloud infrastructure design, and I've done a number of projects working with regulated industries. So let's get started with a quick introduction to GDPR. And actually, I need some audience participation at this point. So fingers on buzzers. Hopefully you can see in your webinar view that we have a poll. So I'd really appreciate it if some of you would submit your answer here to whether or not your organization is currently undertaking any activities related to the upcoming GDPR requirements. So I'll just give you a second to submit your response. And of course, if you can't see that, just let us know in the question and answer section. Okay. Give it a couple more seconds and then we'll have a look at the results. Okay, cool. So for that, the 4.7% of you, welcome to a GDPR webinar. Thanks for joining. But it looks like, okay, so a lot of people have already started undertaking GDPR activities. So that's quite interesting. And actually, as I speak about GDPR and attend events and kind of hear people's experiences, I'd say the number of organizations actually going through some kind of GDPR project or undertaking activities of some kind is increasing almost exponentially now. I was at an event on Tuesday, Computing DevOps Summit, which was a great event, and it was almost twice as many hands went up when I asked this question compared with the last event I spoke at a couple of months before that. So it's certainly becoming an increasingly important and relevant thing for a lot of organizations. So thank you very much for completing that poll. Cool. So let's actually just quickly go through a summary of GDPR. I won't spend too long on this, seeing as though lots of you are already doing some work around it. But essentially what we're seeing with GDPR is a change to the existing data protection rules. And this really covers how EU citizens' personal data is stored and processed and accessed, and how we report on problems if there's a breach. And it updates the previous data protection regulations from 1995 just to consider the new way that we handle data in an increasingly digital world. And there are various other things to do with sort of data controllers and where they're based. And you can easily read a lot more about this online if you stick GDPR into your favorite search engine. But one of the interesting things is the scope in terms of the organizations that it impacts, because any organization that's dealing with a business that's handling EU citizen data also has to be aware of the change in regulation. So that obviously affects companies outside of the EU as well. So potential penalties failing to comply with GDPR, and I will emphasize potential. I read quite a lot of scaremongering around penalties, and there's quite a lot of confusion as well. There's a good hashtag on Twitter. I think it's possibly GDPR nonsense. And if you have a look at that, you'll see that there are quite a few experts in this field who are talking about some of the material that they've seen about sort of penalties. And I read something interesting the other day from someone who's responsible for some of the auditing requirements of GDPR. talking about this penalty structure and how it's always going to be something that's judged against the organization's behavior and also number of failures in terms of audits. But it's still worth being aware that these are the sort of potential financial impacts of failing to comply with GDPR. These are tiered, but there's definitely, potentially pretty serious impact on an organization across industries should either of these penalties be applied. Cool. So GDPR as a standard covers a whole range of business operations. There are 6 key areas, actually. But the most relevant for IT, in my opinion, is this idea of privacy by design. There's actually a privacy by design framework that was first drawn up in Canada in 1990, I believe, if you want to read more about this idea. But essentially it means that any new systems and processes that we're designing and building should have this idea of data privacy at their core, but also throughout the life cycle of its operation. And a big part of this is the idea of being proactive in how you're ensuring data security. Okay, so if we're going to try and meet this privacy by design mandate, there are a few things we need to consider. 3, actually. So first of all, it's important to know your existing security stance. So many organizations have a sort of peak and trough approach to auditing, and maybe their audit schedule is on a sort of 3-6 month schedule. And to actually meet that audit, there's sort of an overhead of work that then drops off between the audits. And so what we often find is that as an auditor is coming into an organization, an IT team that could be working on a different project suddenly has their focus shifted to make sure that they're able to report the state of the systems, but also to apply any changes that are required to get through that specific audit. And the problem with this sort of lumpy approach is that it disrupts our agility. There's an opportunity cost around working that way. It really contradicts this idea of sort of privacy by design, so it's at the core of our daily operations. And it ends up introducing what we call sort of faulty assumptions around the state of the systems that we're operating. And of course, this introduces risk, not only to the systems that we're managing, but also to the business as a whole, should we fail to be compliant with some of our GDPR requirements. Okay, that's consideration 1. So what if we could switch to more of a sort of continuous model? And so if we move away from this tiered sort of lumpy approach to auditing and change, and instead have this kind of continuous auditing on our systems, it makes auditing a much more natural part of our IT operations. And of course, this helps us meet this GDPR requirement of privacy by design. So the second consideration is this idea of a trade-off between speed and risk. So many organizations are doing what we call DevOps. They're working in new ways. They're agile. They're moving quickly, shipping code and application changes often, orchestrating complexity. But the problem with that is that lots of change, continuous change across the environments and systems that we're managing, impacts the InfoSec organization's agenda, which is to reduce risk. And so we have this often this sort of trade-off between needing to move quickly to remain competitive, because we want to make sure that we can ship application changes to our customers as quickly as possible, but we can't be insecure. So how can we find that compromise between the desire to move quickly in the engineering org and the desire to reduce risk as much as possible in the InfoSec org? So that's number 2. Number 3 is this idea of a trade-off between flexibility and efficiency. So we have loads of tools for reflecting the new way of working, right? We can define infrastructure and code. We've got various orchestration tools. We've got awesome build and release tools. But we really need something easy to implement or something that works out of the box because customization is often inefficient. So how can we accurately reflect the organization's specific compliance and security controls in relation to GDPR without spending months on a massive project, going back to that idea of shifting focus and kind of wasting resources, or being restricted by an unwieldy tool set? We need to find that balance between the ability to customize the tools that we need, but also we need something that's quick and easy to implement. Okay, so with those considerations, how can we build GDPR auditing and compliance into the systems to ensure we meet this privacy by design mandate without compromising on the things that I've mentioned, speed, efficiency, and flexibility, but at the same time reducing risk as much as possible? So thinking back to this privacy by design, what exactly should we be focusing our efforts on? Where do you focus to build that privacy? Is it the development stage of your application and your infrastructure as code? The release pipeline? Production? Well, the answer is all of them. And if we think about what's consistent across these different environments, it's really our application and our code base. So the same should be true for how we define our compliance requirements. If we can define our compliance requirements in code, or redefine it in code, then we can have that same consistency as we do with our application code base across all the stages of our IT processes. And of course, this absolutely meets that privacy by design requirement because every stage of our systems are designed to have compliance scanning and auditing at their core. So at this point, I'd like to introduce InSpec. So this is a project from Chef. It's a language, a code base that's incredibly high level, easy to understand, and essentially it's a way to write integration tests for our systems. And there are many ways of running these tests against our systems, which I'll cover in a minute. But InSpec has a great community around it, and as I'll show you in a minute, there are loads of ways to get started quickly with this language and this code base, and also to adapt it to meet some of the requirements of GDPR. Cool, so let's have a look at this example first. So on the left, you can see a typical security control. And if we think about some of the things that you need to be aware of in GDPR, there is a technical baseline that covers things like user access, secure configuration of services. But I mean, if we expand that into thinking about some of the things that we should be considering when designing private systems and secure systems, I mean, data storage is a big one, how you're handling your databases, file system encryption, those kind of things. And of course, your SSH server configuration is going to be a part of that user access. So on the left, you can see a security control that you might find in any compliance documentation. We have a description of the control, the rationale behind it, the actual technical step to carry out that audit, and then also some remediation. And on the right, you can see how we've mapped that documentation into code. And so the code on the right is InSpec. And again, you can see the title, which is the title of the control, the description from the documentation, and then the technical test has been changed so that we have a really simple way of describing what is essentially a command line execution. So we can see what's called a resource, which is the SSHD config. And under the hood, InSpec knows how to go away and interrogate that part of the system to make sure that the protocol setting has the correct value. And once we have one of these controls, we can write lots more and start to group them together into what we call a profile. And a profile is essentially a set of files that contain these tests. And so in this example, I've got my GDPR profile. At the top level, I have inspec.yaml, which is essentially a configuration file. And then inside my profile, I have a controls directory with a number of files. And each of those files is essentially grouping together my tests into a logical group. And I'll show you a practical example of this in a minute. But hopefully you can just about see that in my example on the right, I've got a number of controls, just sort of, blocks of code going down the page. And that forms a profile. And profiles, because we're defining our compliance requirements in code, also allow us to inherit other code bases in the same way that your application code might. So, for example, I can use existing profiles. Maybe there's one from MySQL, for example, and inherit it into my GDPR profile, should I feel that MySQL applies to my system. Now, there is already a MySQL profile. It's a community profile. It's open source. So if I were building a GDPR profile, I can very easily include this profile into my GDPR profile without really having to write much code. And so this flexibility, this way of quickly combining different sets of technical tests is a great way to really speed up your adoption of this kind of tool. Okay, so we've looked at how we can redefine some of the technical tests that we might wish to implement for GDPR, but how can we actually now automate the scanning and the collection of data to find out whether or not our systems are compliant? So automation as a concept is now pervasive in pretty much every business that I speak to, whether it's whether it's sales operations or support or infrastructure orchestration, application configuration, build and release. There are loads of areas where we're seeing automated processes. But for auditing to be that smooth line that we want, that I showed you in an earlier slide, that needs to form part of an automated process as well. So the pattern that we see for regulatory compliance is really this idea of detect and correct. So this two-stage process. And it starts off with this idea of detecting issues and assessing their risk. And then we need to flow through to remediating those identified issues and show the change, because we need to demonstrate to an auditor and prove that we're able to assess and treat risk. And the key thing here is that this is a continuous flow. This is a repeated process, which of course is kind of the core of automation. And we really need that to be continuous to be successful and meet this privacy by design requirement. And so if we map some tools into that, InSpec obviously offers us this detection or assessment stage. We can define in code the things we wish to scan for, the technical controls. And when we run that against our servers, which I'll show you in a second, that's where we're detecting issues. And then on the correction side, we can remediate those problems with our configuration tool of choice. Obviously, I rather like Chef, but the key thing is integration with your existing processes. So if you are using other tools to manage your system configuration, that's fine and can easily handle the correction part of the process that I'm demonstrating. What we don't want to do is reinvent the wheel for GDPR. Think back to what I was talking about around adoption and the speed of adoption and flexibility. If you have to suddenly start using 5 or 6 new tools, then that's not going to make it an easy adoption process. Cool. And if we actually look at some of the use cases and how InSpec maps into them, and I'll go through this in more detail in a second. But in a development workflow, InSpec offers us command line tools and integration with existing testing tools to allow us to verify our changes before they get anywhere near a production system. And then as part of a build pipeline, InSpec can execute and run the tests that we've defined either on some kind of admin or build node or as part of a release cycle. And actually, you'll see that there are now extensions for some of the CI/CD tools to use inspec natively within that toolset. In production, there's an agent-based way of running inspec tests, so you can very easily install this agent on your production systems, and it will continuously run these tests over a defined schedule. And in cloud in particular, there are lots of integration points there. And then on long-lived and legacy systems, you can either execute these tests remotely from some kind of workstation or admin machine, or again, go with the agent-based approach. The key thing is that it's incredibly flexible, and it's all about this privacy by design mandate, making it a natural part of your day-to-day IT operations. Okay, the risky bit. Automating detect and correct verifies our GDPR requirements, but let's actually have a look at it in action. If you give me a couple of seconds while I share my screen, and I'll show you how this works in real life. Okay, hopefully everyone can see my screen. Let's give it a couple of minutes to make sure that it's loaded for everybody. Okay, cool. So what you can see here is a workstation that I have running in AWS in this case. And this is the Chef reporting dashboard. It's showing me the servers that Chef is aware of. So right now, Chef is telling me that I have 5 servers configured to be managed by Chef. Now, as I said, you don't have to use Chef for the configuration bit, but I'm going to show you how Chef can run the test that we've defined in code using the agent-based method along with the command line method as well. So I have a basic overview of the servers that Chef is aware of. Now, right now, Chef isn't doing any auditing or scanning using inspec. And if I hit my compliance tab, you can see in reporting there's no data coming in. But it's very easy to get this set up. So what I need to do to enable scanning against a GDPR baseline is add it to my Chef Automate platform, and I'll demonstrate that in a second, or I'll explain the importance of storing it centrally in a second. But the profile I'm going to use is just an example that I've put together for today. And if you remember back, I'll zoom in a bit. If you remember back to the quick breakdown of a profile, there was an inspec.yaml file. That's the config file, and it just contains basic meta information, the title and things like that. And then if I go back to my code base, whoops, let's go back. Oh, that's a picture of my colleague and I. There we go. Go back to the profile and the controls. These are the test files that I mentioned that contain different tests, sort of grouped logically together. So you can see I have some basic operating system tests. Here I'm checking to make sure my passwd file is set up correctly, that my file system is encrypted, that I don't have insecure packages installed. And again, I've got some tests for Docker here as well, that will only run if Docker's installed. But in this example, I'm making sure that I don't have any end-of-life unsupported images available for Docker. So these are just some high-level examples of the type of tests that you might want to include inside a GDPR profile. So I've zipped this profile up, which means that I can now upload it to Automate and then use it to run against the systems that I showed you a second ago. So let's do that. Upload. And so as part of the upload process, Automate is just going to verify that this profile is in a healthy state, and you can see it's uploaded. And then in my profile list, you can see my GDPR sample baseline. If I click through, you can see all the tests that I showed you are now broken out inside the dashboard, and so I can see and make sure that this is what I'm hoping to check for. So is MySQL running? I can view the code. So that's going to give me a nice way of demonstrating to people outside the IT org the tests that I'm actually running as part of our GDPR baseline. Okay, so to now run this against my servers, I'm going to use something called a role, which is a concept in Chef for sort of logically describing different ways that my servers operate. So I might have a web role, an app role, a database role, and that's going to change the configuration of a server depending on the role. Now, I can also have an auditing role, and I have one here called GDPR audit that I need to finish, but I can very easily assign this role to all of my servers, and that's going to start the scanning process. So there are some settings I can pass into this role that are going to start it off scanning. So the first thing I need to do is set the name of the profile that I'm going to scan with. So let's just call it GDPR baseline. And then I need to get the unique identifier or the profile identifier from the Automate server. So let's head back. And we can see there, this delivery / GDPR sample baseline. There we go. And hit save. So then the last thing I need to do is to make this work on all of my machines. I need to drag my audit role into my base role, which has been assigned to every server that I'm currently managing. So let's just do that. GDPR audit and hit save. So that's it. Now, I talked about a regular schedule. The agent that I have installed on these machines runs on a 3-minute schedule. And you can probably see that from the check-in. It's only a couple of minutes. That tells me the last time that the agent ran. Now, in production, you'd probably want something like a 30-minute schedule. It's completely customizable. You can change it to anything you like within reason. I wouldn't recommend anything less than 3 minutes. But in this case, for demonstration purposes, it's a short schedule. But the key thing is, if you think back to this privacy by design requirement, if I'm able to demonstrate that my oldest data set is within 30 minutes, that's very compelling, not only from a business perspective to understand the state of systems, but also to any kind of external auditor who might be wanting to see proof of the state of those systems. And actually, I have quite a few customers using this who get very excited at the idea of being able to provide data that's sort of 17 minutes old to an auditor. It certainly takes away a lot of the overhead that they currently face in terms of demonstrating the state of their systems. So I'm just going to refresh that and just have a look at the check-in times and see if we've got a few that have run recently. Okay, a few seconds ago. So if I head over to my compliance dashboard, you can now see that I've got data reporting in. One of my servers hasn't run yet, but that's fine. It will appear in a minute. And I can see that right now, against that example baseline I showed you, I have 136 failed controls. And I can break that down by individual servers. If I click through, it's going to show me all of the issues that I have on those boxes, and I can filter them by critical or not. So let's have a look. So MySQL should be running, and it isn't. So it's a pretty simple one to fix in this case, but you can see that I defined in code, I showed you that control to check whether MySQL is running or not. And then within a very short period of time, that control has been executed against my server via the agent, and the result of that test has been collected. Okay, so that's the agent-based approach, which is probably most suitable for sort of right-hand side systems, so production or later staging-like environments. Let me just quickly show you how you can do the same thing on a remote system using the inspect command line tool. So I mentioned earlier that there's many ways of executing inspect. Let's use a CLI. So I can use a command called, actually, let's make that a bit bigger. There we go. Hopefully that's big enough. You can see my typos in huge font. So if I've got inspect installed here, it's part of the Chef development kit. If I hit inspect help, it's going to show me the different commands I can run. So inspect exec lets me run test files against either the local machine that I'm on or a remote system. So I can run inspec exec and then pass in the path to my test file. And if you can spot on my desktop, I've got my GDPR profile there. And then a target machine with -t, and I'm using SSH to connect. Let's grab one of the IP addresses from my Linux machines I've got here. I'll use the FQDN. There we go. The key I'm connecting with, the user, and then I want to allow it to run a sudo. Okay, fingers crossed, live demo. Essentially what this is going to do is execute remote commands, there we go, that are sort of the underlying library from the inspect resources that I showed you on that system, and then check things like standard out, standard error, those kind of outputs from the system to determine whether or not my machine is passing or failing those tests. And you can see in this case, this is a much more developer or engineer-centric view, but I could easily use this output and check things like an exit code as part of a build and release process. So essentially what I'm doing is pushing that scanning for my GDPR controls further to the left, so that not only do I have coverage across the entire life cycle of that IT process, but I'm also able to catch and prevent changes that might compromise my stance against that GDPR baseline from ever reaching production-like systems. Okay. All right, let's get rid of that. So I just wanted to quickly touch on this idea of centralizing profiles and why that's important to give you that consistency and meet that privacy by design mandate. So what I've shown you is Automate, that's the Chef platform. And what it's doing is storing our profile. But you can also store this profile on something like GitHub if you wish, and retrieve the profile from that sort of environment instead of using Automate if you prefer to work that way. Now, think about the stages I showed you. We have a dev stage with our developer, which goes through to build and release. Which eventually goes through to our production systems, which could be in the cloud or could be on-premise. Doesn't really matter too much. So over this side, at the dev and build side of things, we're probably going to want to use the inspec CLI to run our GDPR tests. And what that's going to do is pull the profile down from this central location and then report the results back, either here or as part of our tooling. And then as we move further down the life cycle of this process, this application release process, we're probably going to want to take more of an agent-based approach. So we'd need to make sure, that's the agent by the way, the orange blob. We want to make sure we're distributing the agent across our machines. And then that's going to be much more of a scheduled based approach, maybe on 30 minutes or so, instead of it being a triggered event. But the key thing is that the same profile is, the same profile is being retrieved as was used in the earlier stages. So we have that consistency and the same baseline being applied at every part of the life cycle of the process. And hopefully that really clarifies how working in this way can help you meet that privacy by design mandate. This really puts that scanning alongside the natural part of how this process works. Okay. So let's talk a little bit about implementation. I already talked about the community, excuse me, and how there are lots of profiles already available, which is going to kind of address that idea of the flexibility and customization side of things and how you can get started quickly. But there are already a number of profiles that cover off a lot of the basic technical requirements of GDPR for a range of platforms, and there are many more coming. And these are part of the Chef Automate platform that I briefly showed you as part of the demonstration. But the key thing is that these baselines can form the foundation for your own GDPR requirements, and you can very easily add or skip the things that aren't relevant. Inspect will also soon support platform scanning via the various APIs available. And what it really does is add full stack capability. So that privacy by design requirement isn't specific about systems or applications. It's holistic. And so the ability to audit the platforms on which our systems are running is really key to that. And so there are a few projects running at the moment that are going to introduce platform auditing as part of Inspect capability. And this will be things like security groups, IAM on AWS, those kind of configurations. I've already gone through this, but just to reiterate, there's a command line tool for local testing, which is great for dev and CI/CD. There's also the agent-based approach, which again works in the later stages of a CD pipeline and also production. There's also the agentless approach, which I demonstrated, which is the remote target execution. And one really cool thing to note for anyone looking at container-based workloads is that there are resources for interrogating Docker, the daemon itself, your image lists, and also the contents of a container. Okay, so some further information. There's a dedicated page on the Chef website, chef.io/GDPR. You will find videos, a white paper that was published today, along with links off to some other customer case studies. The Inspec website has some great tutorials for getting started and trying this out yourselves. It's key to note that the Inspec CLI and the language itself is all open source, so you could very easily have your development teams go away and look at this. And remember that Inspect doesn't change state, it only verifies it or audits it. So you can run this against local VMs on your workstations, containers, or systems you have running in more production-like environments. There is also a load of tutorials on the Chef tutorial site, which is learn.chef.io. One thing that's worth noting is that the Chef Community Summit is coming up. It's on October the 10th and 11th in London, and that gives you a great opportunity to not only hear from the people who are writing these tools, but also some organizations who are making use of them. And then the last point is that if you do want to have a look at my my example profile, then you can check it out on my GitHub account, github.com/gardener.io, and then /GDPR inspect profile. Okay, thanks very much for your time. I hope it's been helpful. Do we have any questions?
Thanks, Joe. There's a couple of questions that have come in already, and if you do have questions, please submit them through the Q&A widget, and we'll try and get through them. I know we're a little bit short of time this morning. So first of all, one really around data control. Should a data controller be activating a data purge, e.g. through a config screen in a dashboard on a scheduled basis, or should it be a daily script that is run by a data processor who is working for them? Or do you see as best practice re the GDPR requirement to purge data that goes past a retention period?
Yeah, interesting question. I think it depends on the organization. I think that larger organizations will probably have a more tiered approach. In terms of the actual execution of a data purge, again, it really depends on how you're handling the operation of your servers, right? Because a script could be fine in that case. But equally, if you have more advanced tooling for handling large data sets, then yeah, using some kind of dashboard or config screen could work really well. But I think, to be honest, it's difficult to answer because I think it depends on the size of the organization. If you're a smaller organization, you're going to want to take the most efficient lean process as possible. But then if you're larger, you might have a more hierarchical organization or tiered approach to how you handle responsibility for data. And so you'd probably want to look at a slightly more, not complicated, but detailed way of handling that. Yep. Any other questions?
Thanks. One around InSpec. Are there any business intelligence features built into InSpec?
Yeah, so InSpec itself doesn't contain any of the kind of traditional BI features, but what it does allow you to do is to output the report or the data that's been collected following a scan in various formats and also pipe it through to various systems. So the reporting that I showed you in Chef Automate is based on an Elastic cluster. So you could either use an existing cluster that you have running, or you could use, I don't know, something like Splunk if you wanted, with data forwarders in the Automate cluster. We have some customers who are using forwarding and passing the JSON object that's produced following a scan into their existing BI systems to give customers access. So yeah, I wouldn't say it offers BI features, but it will work alongside and with existing BI systems very nicely.
Thanks. And one more is around PCI. The question, sorry, it's worded slightly funny, but what is your view on handling PCI in algorithms, particularly in black box algorithms?
I don't fully understand the question, but I'll give it a shot. So the InSpec itself comes with a number of resources that will allow you to, natively in the language, interrogate things like MySQL configuration, SSHD configuration, permissions on files and folders, that kind of thing. But if you need to reflect some, output of an algorithm or an endpoint that you're using for testing purposes, you can quite easily just test sort of the output of a system command using standard out. So if you are finding that you want to include maybe some of your existing sort of application testing process within an InSpec run, for example, is this endpoint available? If we run a particular binary that we use internally, is the output as expected? Then InSpec allows that level of customization.